All right, in this video, we're going to go over some multi-step mole calculations. So at this point, you've already moved between mass and moles and moles and mass, and moles and particles and moles. So now we're going to go from mass all the way to particles, so atoms or molecules, and particles all the way to mass. So the key is sort of this graphic here. Right, so if you're asked, or if you're given a mass and asked for a number of particles, you're gonna have to find moles first. Or if you're given particles and asked for mass, you're also going to have to find moles first. So you can't go directly between mass and particles or particles and mass. You're always gonna have to find moles first. Okay, so jumping right into our first sample problem, it tells us we're given 2.54 grams of hydrogen sulfide. We wanna know how many molecules we'll have. So again, right, we can't go directly from our grams to our number of molecules. We're going to have to find moles first. And also always remember, whenever you're given a mass or you're asked for a mass, you're going to have to find your molar mass. Okay, so for our molar mass for H2S, it's going to be 2 times the molar mass of hydrogen plus the molar mass of sulfur, which adds up to give you 34.08 grams per mole. Oops, that's small. Okay. So you can solve this problem in 2 separate steps. So we could take our mass of hydrogen sulfide, so we have 2.54 grams of H2S, and we could use our molar mass to convert from our grams of H2S into moles of H2S. So we'd multiply by 1 mole over our 34.08 grams, and then our gram units cancel. And if we multiply that out, we'd get our number of moles, which is roughly 0.0745. And then we could take that answer, that 0.0745 moles, and convert that into molecules. So there, remember, we'd have to use Avogadro's number. So it would be 6.02 times 10 to the power of 23 molecules over 1 mole. So our mole units cancel, and we get roughly 4.49 times 10 to the power of 22 molecules. My pen is no longer working. Oh. Molecules. There's none there. They're molecules. What you could also do, which I prefer, is actually just writing it all out into one step. So it'd be exactly the same thing, exactly the same steps, just all out in one line. And you'd only have to do the calculation once. So we'd start off exactly the same way. We have 2.54 grams of H2S. In our first step, we'd go from grams of H2S into moles, so we'd use that first conversion factor, 1 mole over 34.08 grams. And then if we were to multiply that out, we'd at that point have moles, but we're not going to do that yet. We're going to do the second conversion, which is to go from our moles into our molecules. So we multiply by 6.02 times 10 to the power 23 molecules over 1 mole. So you can see our mole units cancel and we're left with molecules. So it's really exactly the same thing. It's just you write it in one step. You do the calculation once. So we'd have 2.54 times 1 divided by 34.08 times 6.02 times 10 to the power 23 divided by 1. We get exactly the same answer. So same thing, it's just I like it better written out all in one step. I can see everything canceling and I don't have to worry about punching in wrong numbers in my calculator or rounding problems. Okay, so sample problem number 2, same idea, we're just going the opposite way. So we have our number of molecules, we're looking for the mass. Okay, so I know I'm going to be ultimately finding a mass, so first thing I'm going to do is go ahead and calculate my molar mass because I know I'm going to need it. So it's going to be the molar mass of nitrogen plus 2 times the molar mass of oxygen, which adds up to 46.01 grams per mole. Okay, so let's try the problem out. We have 1.35 times 10 to the power 28 molecules of NO2, so let's write that out. 1.35 times 10 to the power 28 molecules of NO2. And I'm going to, in step 1, convert from molecules into moles, because remember, we can't go directly into mass. So my conversion factor is going to be 1 mole over 6.02 times 10 to the power of 23 molecules. So my molecule units will cancel. And then if I were to do that math, I'd have a number of moles, but I want a mass. So I'm going to go one step further, and I'm going to use my molar mass to get from moles into mass. So So it's going to be 1 mole on the bottom of my conversion factor and 46.01 grams on the top. So you can see molecule units cancel, mole units cancel, and I'm left with units of grams, which is what I want. And the number ends up being over 1 million. So 1,031,785 I think it's 714 grams, which is a very big number. So I'm going to put it into scientific notation. You could also put it into kilograms if you wanted, but it's going to be 1.03 times 10 to the power of 6 grams, because they had to move that decimal spot, or that decimal, 6 places to the left. So that's where the power of 6 comes from. That's my final answer. Okay, so just things to remember. 1, whenever you see mass in a question, you're given a mass or you're asked for mass, remember you always need to calculate your molar mass. So take your time, write it out. Also remember you can't go directly between mass and particles and mass. You're always going to have to find moles first. Okay, so try some practice problems and then try the quiz that's posted.